How are everyone doing today? Okay, thank you. Welcome to Freddie Mac and KPMG case study session. This is to talk about the advanced machine learning on data integration with our common data engineering framework about model robot. We are going to talk about more about model robot. Have you been to this session last year? Anybody been to this session last year? This is our second year in a row that Autogenerated has asked us to present. This is a continuation from our last year's session on Common Data Engineering Framework. Today I'm here with Kevin Martelli from KPMG. Freddie Mac and KPMG partnered to do a solution on Autogenerated platform. Kevin presented the 2017 session. So we are going to talk about 2017 session, some of the core platform features, and how we are going to extend the platform features with 2018 model robot. So I'm Balaji Upatur. I'm working at Freddie Mac as a risk analytics director. Kevin?
Hi, everyone. My name is Kevin Martelli. I'm a managing director at KPMG, and I head up our big data and engineering practice in our Center of Excellence, which we call Lighthouse. And thanks again for all coming, and look forward to hearing some feedback on the presentation.
Is the audience hearing? Are you able to hear us? Yes. Okay, thank you. So Freddie Mac, how many people know about Freddie Mac? Quite a few people. It's good. So we are mostly in the secondary market for mortgages. We work with the lenders and the bankers to do the financing for mortgages. We purchase mortgage from banks, and we keep the liquidity in the market so that the mortgage, home mortgage is affordable and accessible to borrowers. So in our journey, we have an initiative called Reimagine the Mortgage Experience. Within the journey, our mortgage experience is like we learned that there is a time that takes from loan origination till the loan closing, and there is a cost associated for loan origination to loan closing. So in this journey, we are going to talk about what are the benefits that we are giving to lenders and the borrowers. We are shortening the life cycle of the loan manufacturing, and also the fees related to the loans are being reduced. It benefited the borrowers. Our mission is to provide liquidity, stability, and affordability to the US market in all economic conditions and across all communities, coast to coast. So to start this session, we decided to do some recap of our project objective, our 2017 CDF, and what are the model features that we want to build on the model framework, and 2018 model robot, how it got evolved, and what are the features we are delivering part of the model robot. At the close, we are going to do a summarization of the CDF, as well as business values we delivered last few years. I'm going to hand over to Kevin. Kevin is going to talk about the project objective on the 2017 CDF.
Thank you, Balaji. So as Balaji mentioned, last year we did a little bit of work in this space to really set up the foundation. And at the below URL, you'll see the presentation there. But I think in order to get an idea what this new model robot or the intelligent process that we have now added on to this framework, I think it's important to get a little bit of a background. So the challenge that Freddie faced was they were obtaining a tremendous amount of data from their different vendors. And getting this data from a vendor, if you think about it from a loan processing perspective, a loan's made up of many different pieces. And these pieces would come in chunks back into Freddie from the vendor. And they were semi-structured documents, JSON, XMLs. And there really wasn't a very good definition or scheme, if you will, to apply to it. So it took a lot of time for the teams to be able to get this information into their lake, understand the information, and then be able to make the insights. Hence, trying to increase that reimagine the mortgage experience. And I could probably ask the question here today, and many of you will raise your hands. How many times do you drop data into your data lake? You think you know what it means, and then when you want to go figure out what it means, you start looking through all of it, and you have no idea. Then you start following up with the data owner. Well, I didn't own that data. Someone else owns it. And you kind of go through this process. And that was one of the big challenges that Freddie had. So the initial objective was to help design this intelligent automated framework to be able to help accelerate and streamline some of that. So initially, which in 2017, we laid the foundation. We automated a lot of the processes, but at the same time, we were collecting data because we knew in the future, we wanted to make this more intelligent and less human intervention. So we really built it on these 4 key principles or 4 key components. I'll only hit on 1 or 2 of them, but reusability is critical to this. And reusability, not only in the sense of, okay, I have this component, can I reuse it in other scenarios, but reusability in the way we think about our development lifecycle. If I create an ingestion framework where I want to bring in semi-structured data, JSON, XML, et cetera, I want to be able to take that piece and bring on other semi-structured data. And then I might have a model that builds off of that. And I want to have these pipelines built. So I have a pipeline of ingestion, a pipeline of models. And these components I can pick and choose based on the need and put them together in a workflow and then execute similar processes across my landscape. And I think you'll start seeing some of this coming out as we talk through it. But this is one of the, I think, good outcomes of the program. This slide, I want to try to hit on every single point on this slide. But I know this slide is an extremely busy slide, and intentionally so. It was done in this type of way. And the reason behind it is, at its most simplistic sense, in order for us to work on data, it needs to go through, or I guess I should say, in order for us to get an insight, it has to go through many different processes, right? There's a long journey from the time I identify my data sources to the time I realize my engagement or my consumption of that. And if you look through this journey, we all may say the data sources, data integration, exploration, landing, information access. Well, yeah, that's all stuff we have in our landscape, our pipelines. But not only that, but think about all of these supporting processes, all the governance that goes into place, the securitization of the platform, data lineage, data flows, data quality. With the amounts of data that we have today in our ecosystems, is it realistic to even think that we could properly manage and govern all this data? What do we end up doing? We end up looking at core critical data elements, or we end up looking at subsets of data that are used for financial reporting. But most of the time, that's not the data that the engineers and the scientists want to use. So within this common engineering framework in this yellow box here, I'm not saying it takes away the need for all these extraneous processes, but what it does is compensate for when things are challenged in these areas. I may not need the best data governance in place or the best security, but I have a process that can do this automatic identification, lining back up to my data models. It's a pretty significant win. So this next slide we wanted to talk about, this was the common data framework, engineering framework that was built out in 2017. As you can see within this framework, there was a lot of components that we associated to it, and then it kind of, at the top, it moved across the life cycle of the different stages of your data journey, if you will, so from the munging integration and data modeling. And I kind of want to just call out a few of what the initial common data ingestion framework was. So what was it? There was a data discovery component of it. And this was rather beneficial because the documents that Freddie Mac were receiving were JSON, XML, like I said, loosely structured, kind of complex, different attribute names. So when a person would get it, it would spend so much time just trying to read through it, to understand the data, then to be able to create the data model. It just wasn't efficient. So the first phase of this program was, let's figure out a way to easily discover this data. So automatically, their vendors could send in this information into the system. The system would then interpret that information, whether we use the XSD files for XML or different files for JSON, and it would output a result. That result may give you some of the attributes associated to it with some business names and some values, where there are min, max on certain attribute fields that were numerical in value, so on certain categorical values. It helped the domain experts and SMEs to get a better understanding of what this data was. Now, it didn't necessarily solve all the problems, but it was an area that they were able to at least get an understanding and make further inferences to figure out what these data sets were. And then finally, there's a component of it where transformational rules, where you want to have these rules that you apply into your data. Maybe I want to set a flag, or maybe I want to standardize an address field. I want to do some type of activity to this file before I build out my data model. So it gave you the opportunity through the application to be able to enter in these transformational rules. And what I don't want to underplay here, this was all automated, right? I mean, this wasn't something that was kind of piecemeal together. There was a process that outputted these results, integrated with the business, went back into the system, and then ultimately it created the data model. And this data model would be a new data model, or it would be an update to an existing data structure that existed in your platform, predominantly as external Hive tables. So again, it was a relatively robust framework to still have the manual human-in-the-loop process, but help automate the time from discovery to the time you can put some type of action upon that data. And does this problem resonate with a lot of people here today? You get the data, you land it, and you're like, great, now what do I do? Like, who owns it? And you try to govern it, and it doesn't work out as well as you would think. So the common data model, this is the model that we just talked about. It's a different representation of the view. So again, it has the ingestion of the data, it has the business knowledge, the data model, and then it has the output. The part here that we really wanted to sort of hammer home on or talk about was the fact that in this middle box right here, this is where all the hard work was actually still occurring. We weren't able to eliminate our manual processes. So while we were able to create the data discovery document, the domain consultants then got this document and says, okay, I have more information, but I still can't figure out the answer. They would work with business owners, and business owner says, well, I don't own that data. It's owned by data in Joe's desk. So then they go to Joe, well, that came from here. So no one really understood where the data owned, who owned the data, what the data was, so they could put the data in models to actually produce the output. So what the team was able to do is this very manual intensive process. Over the year that this was live, we started tracking and managing all those activities that these people have done, labeling all that data. So eventually, we would be able to have enough information to remove those domain consultants to an extent, still have them in the loop, but remove their knowledge base and have the machine do that for us. So we realized that this was the biggest area of pain for the application. And this is the area that we focused in on, and Balaji will be discussing coming up in the next couple slides. The next one is, once we realized that we had to create a model, we wanted to come up with a framework that was able to, I guess, align to this new paradigm of model development. Tools out there like SAS and SPSS, et cetera, have good frameworks on how you do it, but we wanted something that kind of resonated with our Hadoop ecosystem. And we wanted something repeatable, something that was going to be able to be manageable. So if you look across the top 6 chevrons there, we really look at this as 6 main building blocks, right? So we look at the building block of data processing. So processing the data, making it available in a way that our scientists and engineers can then take that and then send it through a model to get the output. So we had a lot of the data processing work already done from the prior ingestion framework. The next step is the feature engineering part. And this part is very, very critical. It's what features am I able to ascertain from our data to be able to predict the label. In our case, the label and data was the attributes, and the tables ultimately we wanted to fed to. But what were those data fields in this particular object? Model selection. Again, very important is how do you select the right model that can act upon the feature in a way to give you the right predictor. And model development. How am I going to develop it? I have to tune the model based on the parameters I'm getting. What type of model do I using? And this is kind of like a very iterative cycle. And one of the things like we hear a lot about is like these citizen data scientists, right? And I always question to myself, we can push a lot of work off, engineering work, some configuration work, but how do you push processes off like this that have some very complex steps in understanding the data, normalizing the data, picking the right attributes for the data, the right algorithm? How theoretically can this be pushed off to a business unit that may not have the same set of skills to be able to understand it? So I think by looking at this life cycle, you sort of really understand the complexities to get a model that's going to work, to validate that model, and what does that look like? So this was our overall process. Now we did run into an area of challenge in the model deployment, which we're going to talk about shortly. But deploying the model was definitely problematic within the cluster. And then kind of what I wanted to show here at the bottom here, this is kind of a workflow or pipeline. It goes back to the fundamental principles that everything that we've done, we want to have reusability, and we want to have the easiest way to kind of put stuff back together. So for instance, this is the pipeline of what we were doing today, right? And Balaji will jump in more. We have the ingestion, cleaning. These are all separate components in our pipeline. But say, for instance, I have a new use case that comes out. The new use case may not want my relationship-based feature. I throw it out of my pipeline. There's a whole classification of all my components that are available. I can put a new pipeline in here or move something out. So all these things are built interchangeably in a way that you may not like the model I changed for my text-based feature. You could still use that model framework and just retrain it with new data. So the idea is we want to remove the recreation of new data, a recreation of new tools, recreation of new models. And by having your component inventory in conjunction with your models and your ingestion patterns, they're all just being put together into a framework, into a pipeline. The final slide I wanted to just briefly touch base on is, how many people here in the room today have deployed any models inside of their cluster? A couple people. And then how were you using PySpark or different tools? So you create the model and then you serialize the model, right? And then you call it in a batch form, right? Maybe. But then how do you do some of these other activities that are important for the model management? So for instance, how do you have track versioning of your model? What model version are you using? How are you doing A/B testing? Are you extrapolating out your feature engineers? If you're using Spark, how do you access it via RESTful service, Livy or some other capability? So there's a lot of complexity, I think, in the overall ways that models are managed, and they're not always managed right? And they put them in the cluster, they leave them alone, and there's challenges. Now, if you look like a tool like SAS, they have their SAS model manager, which is pretty mature. But there's not many companies out there that provide capabilities to sort of holistically encompass this space. I mean, you do have data science experience, but it doesn't solve this need.
Sure. So what we did was we actually engaged with Hortonworks. They sent us the guy who basically wrote the book on Python. And what we did was we decided very early on that we would have to establish this entire sort of framework,
Yes.
beginning to end.
Yes.
And he gave us really good practical guidelines around how we could establish, this pipeline beginning to end. So the governance and everything around how we would actually deploy models, manage versions, everything was built into our CI/CD pipeline.
Yep.
And so we manage it in that way. Look, it didn't solve for all of our problems. We started to deploy against a certain sort of method, and we had it all laid out, and the options seemed very good. Then later on, we realized that actually, we don't want to deploy in this fashion anymore directly just on cluster. We would want to deploy this out.
And then I suppose I want to deploy a SAS model, right?
Yeah.
How's it going to work in those scenarios? So, and I think at the end of the day, what we wanted to show, it's very problematic, and there's some things we put in place to handle that. A model versioning database, which was Hive, and then there's the warehouse, and then everything we did, again, was componentized. So you can call a feature in many different ways, and then ultimately serve them up through some type of insights of an API. But I mean, the point being is that a lot of us create these data science pipelines, and we're proud of ourselves, and we deploy the models onto the cluster, and then it's like, well, how do you use it? Well, I'm using it in batch processing. Okay. Now, how do you know what version? And then especially when you start putting more critical business processes onto the cluster, right? And if anyone in financial services, there's tremendous, they're only using regression, right? Because it's so easy to trace through the process and they can see it. How does that work in these types of scenarios? And how do you get those audit comfortabilities over that? For this really to go mainstream, these problems need to be solved. And they're not easy. But I think it's something that, again, it shows the capabilities, and it's still maturing. So hopefully we will get there. But with that, I'm going to turn it over to my partner in crime. And he is going to go through and talk a little bit about our actual model robot. Any other questions before we can take some at the end too? Okay. To you, Balaji.
This model robot, as you see, we got different data sets, and we have been working on the large data sets with our lenders and our bank customers. So we have leveraged a lot of our common data framework data discovery process. Once in the data discovery process, we started looking into the semantic layer, right? Like what the data is, what type of data is, what the data can be standardized. And we started looking into the data insights. For example, what is the noise in the data? How can we identify noise in the data? How can I separate the noise from the data and take the data that is really needed for our business context instead of having the entire data? So model robot is one area where we decided we can leverage all of our SMEs, domain experts, intelligence, and we can start building as an intelligence model that can learn the data sets and spit out a prediction model for us so that our domain experts can see the prediction model and pick and choose, saying, yes, this attributes makes more meaningful for us so that we can leverage this for our business decision purpose. So I just want to see a real-life scenario like today. We have all the social networks. I think people are registered to social networks. I like to see who is not registered in the social networks today. I think everybody is registered, right? So we get an invitation from unknown person saying, I want to be part of your network. So your invitation is going to stay in your inbox. Now you are going to start building your intelligence on the invitation, saying, OK, who is he? Why did he send his invite to me? What is the value we are going to see part of that invitation? And is he part of my network of people? Are we having any value part of our business side, or is it personal side? So we humans ourselves are building that intelligence so that we know that how can we identify the noise, how can we separate the noise, and make sure we accept only the value of that person, right? So that's where we said model robot is where we want to build that intelligence so that, like the vendors are saying, we have the entire data set. You can use it for your business purpose. But we need to identify the noise, separate the noise, and build only the business context from the data. So here is what we did in the model training. So first, let's say on the left at top, we have our target data model. We picked all our target labeling there. Now we have the vendor input files, which is all semi-structured. We have JSON, XML, ORC data formats. Then we said, we will learn from the source descriptions of the data integration. Then we leverage our model framework where we have to go through the 6 phases of the model. We leverage our model framework. We started consuming the vendor data and input to our configuration model. Once we build that configuration model, we started looking into the features. If you see the features, we started numerical feature, text feature, and the relationship feature. So as the classification engine, the data modeling and the analytical packages we used is some of the Spark libraries and some of the scikit-learn, NumPy, and also some of the NLP packages. As the data comes in, we have to see the data profiling part and the data discovery of the source. Then we started building our feature engineering based on the source. Then from the feature engineering, our model is being trained to see the data. And eventually, we get a predicted model as a model ensemble. So there is an article about how this entire learning is published. It's Don and Domingo's article, which gives more insight about how we can learn from the building a model. So I would just want to give a quick example. As this model is built, you can persist the model in your Parquet format, as this model is output to our Hive data set, so that our business SMEs as well as domain engineers can leverage that model output. And the model entire prediction is stored in our pandas frame. So we just give an example. We took one of the new vendor file. We first run this model with our 1K data set. They had around 300 attributes in that model. Then we started doing some training with the data. Out of the 300 attributes, we could able to successfully map only 20 target attributes. That means the noise, there is so much noise in the data, we could leverage only 5 to 7% of the data from the vendor file. So what happens is there is a prediction accuracy. Once a prediction accuracy is reached, the domain experts will see the output of the predicted model, and they can pick and choose, saying, we can leverage these few additional data elements for our business needs. Out of this entire thing, it's run in Hortonworks platform. It's fully automated. I just want to walk through how we are doing this entire prediction model. Previously, we used to have domain experts and SMEs sitting outside that entire process because they were manually reviewing all these attributes, and they started building the business context of the attributes. Now, as the new vendor file comes in, we started doing the data discovery part of that vendor file. From the vendor file, we are feeding to our feature engineerings, which is our text base, numeric base, and also our relationship algorithms. Then we have our machine learning algorithms in between. Based on the features, our machine learning is running on the data sets and predicting models is output as our outcomes. Then our business SMEs will leverage and see, then they will fine tune the data set. Then it goes back to our continuous learning so that as more and more data is being identified so that the noise is not processed in our data sets.
Any questions?
Yeah. I can walk through in the next slide. We have the detail of each feature. What are the different classifiers we are used for it?
You've got to continue feedback loop on that to make sure that you're getting accurate results and sort of measuring
Correct. For example,
basis. But what are you doing around monitoring the actual performance of the model, if anything? So from an error logging perspective, also whether this thing is actually starting to run really slowly versus
Yep.
well, anything of that nature, and if so, how?
So good questions. As we have this lot of data sets coming in, we'll fine tune and try to partition and run it in different partition levels so that the performance are met for us to do more prediction model. One more question.
So how do you filter the noise? Like you said, like you fine-tune, you get the data, you identify the noise. But when it goes back to the free input, right, are there filters assigned upfront so that in the continuous pipeline doesn't the noise will come?
Correct. So we train the features so that we can enhance our particular feature. Say there is a lot of noise. A good example is there are a lot of null indicators or null values coming in data set, right? So in our feature, part of the text feature, we try fine-tune that, saying that if you see some of these features that is not needed, we'll filter out in that space. Some of the integer features where there are a lot of negative values we get, right, which is meaningless because some of those information is being captured for the transactional purpose or for temporary purpose. So part of our feature engineering, we'll refine and make sure that that noise is being taken out so that our model can pick into that values, appropriate values. So that's a good question. So as we said, our prediction rate is 69%. Once we know that anything that goes above or below within that neighborhood, we can see that whether the values are being correctly meeting to our needs or not. So the SME, the human in loop, will make a judgment call. Instead of he's going to review all the 300 attributes, the one which got predicted, he will be reviewing only those attributes. So that gives more value instead of identifying all the 300 attributes. Now the predicted only neighbors will be identified and the false positives are being addressed there. So if I start, this is a detailed depth into each one of the features which we talked about. As first the data discovery is done, the three features we talked about is numeric-based features, and text-based features, and relationship-based features. In the numeric-based features, we try to see whether the values are properly coming in, min, max, medium, and also some of the mean values, so that we know that model and our target, the target numeric-based values also meet to that, right? Then in the text-based features, we started looking into the position tagging, as well as the string tagging, as well as NER tagging. Once we define that these two features are being fully trained, then we started looking into the relationship features where what is the nearest neighbors of the data? Is there any one attribute or many attributes which is nearer to that for that feature? Within that features, I just want to give you some of the models we used in our program. We used random forest for numeric feature. We used naive Bayes for text features. And we used cosine similarity for our relationship. So finally, it's based on our feature extraction and the models here, we got a modern ensemble for our users.
Maybe to add just one thing is, through the process, and just to make sure that we're thinking back to the business problem, there's a huge values in these XML and JSON documents. And in those documents, thinking, kind of phase one, these features, whether numerical, textual-based, relational-based, can then be leveraged to help predict. But as you kind of like look through and better understand the data, you're going to have a whole lot more learners that you're going to be able to apply into these data sets to get and refine out or I guess to better refine the accuracy of your output.
Yep. I just want to take one example and walk through that entire, new data set that's coming into our pipeline. Say we got a new data set coming from a business area, and they want us to see whether we can leverage some of the data for our business stations. So once we get the data, we started running our data discovery process that identifies all the attributes in our source across all the files. Then it gives us an output saying, example here, we just picked two attributes. One is like a numeric attribute, and one is like a text attribute. And there are the different hierarchical paths we are available in that files. Once we know that the attributes are being identified and the ranges and the information is being provided, then we'll say, let's start our future extraction process, because now we know there are attributes out and the ranges are there and the values are provided. That's where we know that, the noise, how we can eliminate the noise from here, right? So we use the numeric patterns, numeric algorithms, and the text algorithms so that we know which feature will be used for each attribute. Then once we have it, we know that then take the path for that attribute and see how that relates to our target space. These are the three algorithms we used for our purpose for text, numeric, and relationship. And finally, based on the data set, whether it is a text data or a numeric data, it predicts an output saying, this is the predicted value I'm saying for available balance, which came in this file. It predicted to an asset account balance, which is in your target space that your business is using. And for asset type attribute, it predicts an output saying in account type, that's what is closely matched neighbor. This is a relationship we found out. That dashboard output goes to our SME. The SME says, yep, it makes sense that the values are being in the range and the information is there. And we can leverage this output, and so that the source of the data that goes into the target space, these are all done within hours and minutes that we can process large data files. Sure, question?
So in the discovery phase, it's more extracting the columns of each file.
Yeah.
Was there ever consideration going to take a step further and make it a standardized model to make sure to make future extractions have
Like a curated data set.
Yeah. Yeah. Yes, it's possible that we can enhance our model to accept that one too.
No, but I'm just curious, was it a consideration or is it just you still working towards the journey?
It's towards the journey, right? So right now, we know for any given file, there is a value out there or not, so that we'll go back and give a feedback to our lenders or the data provider saying, your data you gave, it doesn't meet our requirement, right? So then they're going to ask you which data fields you're looking for. We clearly see the output from here saying, we matched only 5% of your data, your 95% is noise. Can you give us more meaningful data? Then they go back and say, okay, there is another batch we can provide for you. So we run this model again. Then it gives more closer, predictions. So on the CDF outcome in the summary, I just want to bring in all what we initially planned. CDF is supposed to be a reusable, extendable, and full data ingestion framework. It's full custom built, and it is a patent pending model that today we have it. Any data sources which are structured, semi-structured, or unstructured data, we can predict the data and we can able to process the data today. The data comes to us in the pipe, and we have our business rules component within the CDF framework. We'll match the data and apply the rules, then it goes for analytical purpose. So instead of saying it takes days, months, years to do some data understanding and data usage, we can do in hours and in a day that we can understand the data, what we got it. The business values. So on the 2016, as this program, we said, reimagine mortgage experience. We initially started working on the data munging part, where we want to build a framework to consume all this data. It took us almost 3 to 4 months to build reports from where the data was originated and to do an end user reports and end user models. In 2017, where we reduced a lot of our time and we could able to produce reports in next day because our framework able to process different type of data sets. And 2018, now with having this self-learning model robot, we're able to now even reduce our engineering work instead of waiting for the data models to build. Now we incorporated that even the model within our framework. By 2018, we are expecting we can still reduce a lot of our engineering time so that we can do a intraday and day one reports in more faster. That's the goal for us. Any questions?
Uh-huh.
It's here. So instead of we saying that humans has to do the entire work, now we have a predicted way for humans to say that these are the top category or top identifiers, make a judgment, and then recommend for it. So we isolated the noise. We separated the noise from the data. We are now taken the data which is meaningful for our business to make a recommendation.
So it's kind of what we did in the first stage, where we were just collecting all this data, and then we can train it. In this stage, we still don't know how perfect it is. It's 70%. So when it comes out, someone's still going to have to say, I agree, let it flow. The ones that are off, save them. Once we build up enough history, that can then be repushed through the model.
So along the same lines, in our example, they had a capability of taking the model, pushing it out to the car, and then based off of new information, they would actually push that information back and then regenerate the model with the newer information and push it back out. That obviously didn't have the human in there. Is that what you're suggesting?
Well, I mean, maybe that could be some ways based on what that model is, but I would say for a lot of the team, we have one of the lead scientists here, Emmett Pan, who worked on this, that you want to be able to validate the models that are coming out and making sure that you're getting the accurate results. I would feel very uncomfortable if I have a continuous learning machine, and depending on what that task is, I'm deploying those new updated learnings automatically without anyone giving a validation that what is coming out is right. And you could, especially more financial.
The financial where we have to do more decision making.
I mean, just think of something like in the car example. If you have an automatic car that's driving on a machine learning model, and all of a sudden new information comes in that you think you can enhance the effectiveness of that car, would you trust receiving that information and acting differently without really having fully vetted that out?
Identify the new relationship, right? I think that's kind of the function of the model. Do you look at the definitions coming in the data, or do you actually go and find out in a powerful way looking at the data as well to discover the relationship?
It's possible, right? If there are new attributes, or for example, there is a new business that's driving and adding new attributes. Like a good example in IoT today, there are a lot of devices. Every device has its own way of producing data, and it changes over period, right? In that time, this model is able to do a self-learning, saying, I have new data elements coming in today, part of our engineering framework. It logs us out saying, there are few new attributes came for today's file, and these are the few new attributes or few new attributes that's been displayed for us.
I think in the Hive space is relatively easy because most of the time you have new metrics or release couple of things. But more in a relational data, right?
In this example, it's a JSON, so quasi-relational, semi-right. But I think what it does is it independently looks at textual data and independently looks at integer or decimal data. independently and tries to determine if there's a way there. For the relationship part, it looks at the XPath or the string for that path and then say, is there a relationship based on what I'm finding? Can I now also correlate that? I think it was in this slide here. You see how these two are sort of connected because these are sort of independent. Text are categorical. Then it goes into the prediction of cosine similarity. And at that, it's not really an algorithm per se, but it's looking at where it flows on the cosine chart. So, you know, if it's here and here, they're definitely not alike. So that is again more of a comparison after the fact, and that might make different predictions. And at the end of the day, the model will take whatever the best prediction is, or the common prediction between both of them. Hey, thank you all very much.
Thank you all for attending this session.
Thank you. One other thing, we're going to buy everyone lunch today, so it's in the other room.
It's in the other room.
So thank you for coming.